My dear students, myself Sachin. I am continuing the topic of highway engineering, that is pavement designs. In pavement design, we start up with the design of flexible pavements. So, in the previous video, we have already learned flexible and rigid. So, we have already know about the types of flexible pavement and types of the rigid pavements. What are the difference between the flexible as well as the rigid pavements? Now, we will concentrate on design of flexible pavements. So in the previous video we have already learned in flexible design in subgrade will be there nothing but natural formation of a ground, nothing but this one is the ground. After that formation level, that is maybe due to the sub base. After that base course. Over that surface course. Over that wearing or nothing but movements of vehicle course. This will be our wearing course. So totally there are 1, 2, 3 and 4 layers will be there. So and we know already the thickness of the each layers. Now we need to concentrate on design procedure. So first one, these are the examples of the flexible payments. This may be made up of a bitumen or asphalting. So we can see here clearly. And these two are the example for rigid pavements. Here they are taken only 2 or 3 layers, sometimes 1, 2, 3. Sometimes they will go only with 2 layers, sometimes they will go with the 3 layers. So in this picture we can clearly see in rigid pavement based on the natural formation, sub base will be common for the both types of pavements. Over that directly rigid pavement, that is nothing but a concrete. But in the flexible, base course, surface course and surface stretching, nothing but a prime coat like this will be comes under the flexible pavements. Next, wheel load, nothing but when a wheel is moving, assume this one is a single wheel load. Single wheel load, the load will be transferred gradually over the granular structure with the stones or aggregates provided below the wheels. This will be able to the transfer of loads from the wheels, that is P. Wheel load distribution, how the load will be distributed. In this picture we can see wheel load, the wheel is moving like this direction, the load distribution will be like this. Usually we will in the flexible design we will consider it as an parabolic curves. Surface layer, the wheel is moves rolls over the surface layer, the load will be continuously transfers like this, means the load transaction will be like this whenever the wheel is moved one over to another. We can see here clearly the load is distribution gradually. Next, this one is the cross sectional of the flexible pavement. So surface course, base course, sub base, subgrade. These four are the main ingredients already known. In flexible, this picture gives the most important information about the flexible and rigid pavements working phenomena. Whenever the load P is acting on a flexible pavement, and assume the same load is acting on the rigid pavement also. Here we can see the nature of the stress distribution. This will be more comparing to the rigid pavement, because the rigid pavement the stress distribution will be very less, but in compared to the flexible pavement. Next, jointed plane concrete pavements. In already known in jointed plane concrete pavements, there will be a bars, nothing but in concrete they will construct the roads with the continuous bars, longitudinal as well as the lateral directions. So this typical spacing, see here clearly, the typical spacing will be 3.7 to 6.1 meter. or you can call it as a 12 to 20 feet. So these are called as in longitudinal bars. Longitudinal is nothing but along the lengthwise. If the length of the road is moved, the lengthwise the bars are placed. These bars are called as in longitudinal bars, and these bars are called as in tie bars. These tie bars are connected to the longitudinal and transverse loading. Side view. Here we can see the dowels and transverse joints. See here, the direction of traveling is like this. So longitudinal bars will be like this only. Here the direction of traveling is north direction. So longitudinal direction of bar will be along the north direction only. Next, jointed CC pavements. In jointed CC pavements, the longitudinal bars are placed along the length of the road. But for particular distance, that is L, that should be a contraction joint. Because of the varying in the temperature stresses, the steel may be subjected to, as not only steel, the whole concrete pavements will be subjected to expansion as well as a contraction. To avoid that phenomena, we should provide a expansion joints or contraction joint that should be equal distance to the L, equally distanced. So these are the dowel bars, these connected with the longitudinal and cross sectional bars, and these are the tie bars. In the examination, they may ask what are the jointed CC pavement roads. Next comes to load distribution. As already learned, in the flexible pavement, the load distribution will be more comparing to the rigid pavement. In rigid pavement, the load distribution will be less, and the developing of the stresses will also less. In case of the flexible pavement, the load distribution will be more. Next, components of flexible pavements. This one is the most important question, and we have already learned surface course, base course, subbase, and subgrade. Next, functions and significance of subgrade properties. What is the functions? So here the first course is subgrade. When you are going from the bottom 2, 3, 4, subgrade. What is the main function? This one is the basement for the soil off road. Yes, it is correct, because this one is the most important basement. When we are constructing a structure, the basement is required. Like that, when we are constructing a road, the main basement is nothing but a subgrade only. Next, important for a structural and pavement life. If the life of the subgrade goes decreases, automatically the life of the road is also decreases, because the strength of the road is wholly depend on subgrade only. If assume if the subgrade is uh, blacky soil, nothing but a black cotton soil, BC soil, automatically bearing capacity will be less. In such cases, we need to completely refill the soil with the moram. That's why for the construction of road purpose, 99% usage of moram will be done. Should not deflect excessively due to dynamic loading. Assume we have constructed a road for 18 tons to 20 tons. Continuously 30 tons capacity of vehicle is moving, or more than 30 tons, automatically the road may be subjected to failure, maybe in fill or embankment. Next, flexible pavement design. According to IRC 37/2000, there is some regulations for design of flexible pavement. Now, first one, basic principle. What is the basic principle? Vertical stresses or strain on subgrade. Second, tensile stresses or strain on surface course. Next, factors for designing pavements. What are the main factor? First factor, design of wheel load. Second factor, subgrade. Third, climatic conditions. Fourth, pavement. Fifth one, environmental. And the sixth one, traffic characteristics. What type of the road traffic should be considered. And the last one, cross sectional elements of the load. First one, design of a wheel load. In design of wheel load, three more load cases are there: static load on wheel, contact pressure, and load repetition. Usually in construction of the flexible road pavements, there is a fatigue load in nature, because assume our vehicle is moving in this direction, there is a distance between the front wheel to the back wheel. So this one is not a sudden loading, and this is not a gradual loading, and this is an impact loading, nothing but a series of successive load with a particular time. This type of the load is called as an fatigue in nature. Next, contact pressure and load repetition. Pavement response under the loading. As we already learned, in a flexible pavement, the load distribution will be like a parabolic curve, and surface base course subgrade. Usually axial load is transferred from bearing course to the subgrade. So this brief picture will give the idea of the type of the lanes, the types of the single axle, double axle, and depending on the loads. Here an axle is a central shaft for a rotating wheel or gear. The first case, a single axle with a single wheel. Here we can see only single axle is there, and the maximum load carrying capacity is 6 tons. In case B, single axle with dual wheel. Here 5 plus 5 around 10 tons will be applied. Compared to single axle with single wheel, the load will be more here. And the third case, that is C, tandem wheel. Here the legal axle load will be 18 tons, nothing but more than the first and second. And the last one is D, 24 tons. This one is the heavy tonnage vehicles. So we can see here 24 tons vehicles